Hello again, year 10, and in our third lesson on surds, we're going to be looking at the work that we did last lesson, multiplying some surds and seeing how this can be achieved with a single bracket and also a double bracket. But before we get started, let's just have a go at 5 quick questions expanding brackets using algebra. Bearing in mind that we've just come out of the topic of quadratics, I'm expecting this to be absolutely fine. So you could do this in the back of your book, or you could just do this mentally. Pause the video here because I'm about to go through the answers. So for these single bracket problems, it's just a case of multiplying by the number in front of the bracket. So in this case, we get 5 times x, which is 5x, and 5 times -2, which is -10. Question 2, we're multiplying by 9. So 9 times 3x is 27x, and 9 times +1 is +9. The third bracket, we are multiplying by an x, and x times x is x squared, and x times -5 is -5x. For number 4, we are multiplying by 2, so we have 14x and 4y. Finally, question number 5 is a quadratic. I'm going to expand this using FOIL. So 3x times 2x is 6x squared. Outers, plus 18x. Inners, minus 2x. And lasts, -1 times +6 is -6. Do note that this one does simplify though, so it is 6x squared. Combine your terms in x is plus 16x, and then take away 6. So I hope you've been able to print out a sheet for today's lesson. If that has not been possible, can you please remember to put the title, Surds 3, and the objective, be able to expand brackets with surds. Do not forget today's date. So what we're going to see today is if you can multiply brackets with algebra and you know how to multiply surds, we are going to be able to do the exact same thing. It works in the exact same way. So we're always going to need to check if those surds simplify, or if we have, say, the square root of 16 that equals 4, that we can write some of them as integers. So always things that we need to check once we have done our answers. So let's start by looking at some single bracket problems and then see how we can expand this to 2 brackets. So if I have 2 bracket root 5 take away 8, I'm doing the exact same thing as I did in the starter activity a moment ago. I need to do 2 times root 5. Well, that is just 2 root 5. And I need to do 2 times -8, and 2 times 8 is 16, so it is -16. I cannot do any more with that expression. It doesn't simplify any further. Okay, in my second example, this time I don't have a whole number out the front, I have a surd, so I'm multiplying everything by root 3. And root 3 times root 7, remember we can multiply the numbers under the square roots, is just root 21. And root 3 times 1 is just root 3. And neither of those surds simplify. Final example, let's multiply by root 2. Root 2 times root 5 is root 10. And root 2 times root 2 is root 4. Now this one does simplify, the root 10 doesn't, but root 4 is 2. So I could write this answer as root 10 plus 2, or if you prefer, 2 plus root 10. So far so good with single brackets. So let's up the ante by having a look at some double bracket problems. And the maths that I'm going to use here is still FOIL. I'm going to be multiplying each part first, outer, inner, last, as if it was a FOIL question with algebra. I will be doing a lot of working out and simplifying as I go along. So the first question is root 5 take away 8 times root 5 take away 8. So I will do the firsts first. Root 5 times root 5 is root 25. Now the outers. Root 5 times negative 8 is negative 8 lots of root 5. Let's do the inners. That also is another negative 8 root 5. And now I'll do my lasts. Negative 8 times negative 8 is positive 64. So there's a little bit of tidying up that can be done here. First of all, the square root of 25 is 5. And since these are both multiples of root 5, I can put them together. And if I have negative 8 and another negative 8, that is negative 16 root 5. And then I have 64. So altogether, adding the integers, I've got 69 in terms of whole numbers, take away 16 root 5. Let's look at my next example. I'm going to do first outer inner last again. Root 2 times root 3 for my firsts is root 6. Outers is just 1 times root 2. Well, that's just 1 root 2, which I'll write as a root 2. For my inners, I just have 4 times root 3, which is 4 root 3. And my lasts is 1 times 4, which is 4. Now let's look at these surds. None of these surds simplify. None of these surds are the same, so I can't collect any because they're not multiples of each other. I cannot do anything more with that one. It does not simplify any further. That's quite unusual in an exam question, but it's not entirely impossible to have a question that doesn't simplify. Let's look at my next question with some root 7s. If I do my firsts, root 7 times root 7 is root 49. My outers is negative 2 times root 7, so negative 2 root 7. My inners is negative 3 times root 7, negative 3 lots of root 7. And my lasts are negative 3 times negative 2, which is positive 6. Okay, there is some tidying up to be done here because the square root of 49 we know is 7. These are multiples of each other. So we have negative 2 root 7s and negative 3 root 7s. Well, altogether that is negative 5 lots of root 7. And we've got plus 6. And of course I can combine these whole numbers. 7 and 6 is 13. So it's 13 take away 5 lots of root 7. In some of the questions that you see today, you might see the squared symbol. But just remember, that means you are taking the bracket and timesing it by itself. I would always write that out first. Let's do FOIL. Root 2 times root 2 is root 4. I'll worry about tidying that up in a minute. Let's do my outers. 9 times root 2, 9 root 2. Let's do my inners. Also another 9 root 2. I'll combine those in a moment. And then my lasts are 9 times 9, which is 81. So we have 2. A 9 root 2 and another 9 root 2 is 18 root 2s. And we have an 81. So I need to combine my whole numbers together, and this one is 83 plus 18 root 2. For my final example, you will notice something special about these brackets. The brackets are the same, the only difference is their signs. We have seen this before in algebra, and we've called it the difference of two squares. Sometimes gets abbreviated dots. Difference of two squares. And you might remember in the algebra version, it's quite interesting because some terms cancel. And we're going to see the exact same thing here with the surds. So let's start this one off. Let's do the firsts. The firsts is the square root of 6 times the square root of 6, which is the square root of 36. Then we have the outers, which is 3 times root 6, so that is 3 root 6. We then have the inners, negative 3 times root 6, negative 3 root 6. And we then have the lasts, minus 3 times positive 3 is minus 9. So let's do some tidying up. Well, the square root of 36 is 6. But have you noticed what happens to these two surds? The plus 3 root 6 and the minus 3 root 6 cancel each other out. So they've gone, and I just have the negative 9. So for this one, it is 6 take away 9, which is just negative 3. So another example of where the question had some surds in it, but the final answer came out being a whole number. So there are some questions for you to try, and I have just noted that I would probably do question 2 before question 1, mainly because they are one bracket problems and they might be a little bit easier. So I'd go back to my PowerPoint, please, find these questions. There are some questions on some further slides should you be able to get a little bit further today. Remember to use the last 5 minutes to check your answer with a different coloured pen. If you've got something wrong, make some corrections. Can you spot your mistake? And as always, if you've got any questions, you may ask in the Ask the Teacher channel.